All right, so do you all have this out? You guys ready to go with notes? We get 6.4b, solving polynomials by quadratic formula. So the first thing that's important for doing these notes is, do you guys remember what the quadratic formula is? A mixture of yes and no. So what was the quadratic formula? So it's x equals negative b plus or minus square root of b squared minus 4ac all divided by 2a. So yeah, that's the quadratic formula, and that's what you can use when you have something that's in the form of ax squared. Ax squared plus bx plus c equals 0. So that's the main thing to remember when you're doing anything with the quadratic formula. And then when you're looking at the steps of how to solve a polynomial with a quadratic formula, the first step is always get into standard form. Which just means that it equals 0. So getting into standard form, making it equal 0. So getting it to look something like the ax squared plus bx plus c equals 0. The second step is to factor out the greatest common factor. So we'll talk a little bit more about what that means in just a second. But factoring out the greatest common factor. So that's just, if you have something that can be multiplied by everything that you have, you can take that out and put it in front of everything in parentheses. So we'll see what that looks like when we go to number 1. But that's the second step, is just factoring out greatest common factor. And then the third step is just using the quadratic formula. So the steps of doing it are getting it into the standard form, factoring out a greatest common factor, and then using the quadratic formula. So what that looks like is with number 1, which was on your guys' paper, number 1 is 3x squared plus 27x, 3x to the third. You're right. 3x to the third plus 27x equals 0. So that was number 1. And then, so is this step 1, is that in the standard form? Yeah, so step 1 is done. It's already in the standard form. And then the next step was factor out the greatest common factor. So here, when we're looking at it, what would be a greatest common factor? 3x. So see how here we have a 3x to the third, and here we have 27x. But we can take a 3x and factor it out, and then what do we have left? So then we have x squared plus 9. Because if you multiply 3x times 9, that's how you're going to get 27x. And still, that equals 0. So now we've factored out, now we want to figure out what our solutions for x are. So for this one, it's really easy, because what's going to make this part 0 when we're looking for our solutions or for our zeros of this equation? What's going to make this part 0? If x is 0, right? So if x equals 0 here, that's going to make 3 times 0 is 0. And this whole thing is going to be 0. So if we have x equals 0, that's going to make everything here equal to 0. And so that's a solution for x in this part. But then here, we have this quadratic. And this is where we're going to do step 3 of using the quadratic formula. So the first thing that we're going to do with thinking back to the quadratic formula is figuring out what our a, b, and c are. So here, what's our a going to be? Yeah, our a is going to be what's kind of in front of the x squared, but here that's just 1. So a is just 1. What's b going to be? What is it? So our 3x is on the outside, and we're only looking at this quadratic part on the inside. So our b is actually just going to be 0, because in this quadratic, there is no b. So it's going to be 0 here. And then what's our c? 9. So if we're looking back at the quadratic formula, x equals -0 plus or minus the square root of 0 squared minus 4 times 1 times 9, all divided by 2a, which is 2 times 1. So with this -0, that's just going to give us 0. And then, so we're going to get plus or minus, because that 0 can just go away. What's 0 squared? It's just 0. So then we're just going to be left with the -4 times 1 times 9, which what's that going to give us? So -36, and then all divided by 2. So when we have the square root of -36, what's that going to be? So we're going to get the square root of 36 is 6. So we're going to have this plus or minus here that's going to give us x equals -6. But we have a negative there, so what's that going to make it? I. So we're going to have x equals -6i divided by 2, and x equals 6i divided by 2. So can we simplify these anymore? Yeah, because we can do 6 divided by 2, right? So what we're going to be left with is just x equals -3i, and x equals 3i. So here, then we have these 3 solutions for our equation. So x equals 0, x equals -3i, and x equals 3i. So these are the 3 things that we're looking for here. Do you guys have any questions? Do you follow that first example well enough? Cool. So we're going to look at the second one, which was 9x squared minus 11 equals 6x. So what's going to be the first step with this one? Yeah, subtract the 6x. So we subtract the 6x from both sides. Then we're left, then we bring it down and we get 9x squared minus 6x minus 11 equals 0. So now, do we have it in the standard form? Yeah. So then what was our next step? Factor out a greatest common factor. Can we do that here? Is there anything that all of these things are multiplied by? No, there's not. But it's already a quadratic. So we can just use the quadratic formula. So we're looking at this one for the quadratic formula. What's our a, b, and c? A is going to be 9. Those kind of look similar. B is going to be -6, and C was -11. So when we set that up, then we have x equals -6 plus or minus the square root of -6 squared minus 4 times 9 times -11, all divided by 2 times 9. So when we're trying to figure this out, we're going to get x equals 6 because that's just -1 times -6. It's going to give us 6 plus or minus square root of all of this stuff. So what's -6 squared? 36 minus what's the 4 times 9 times -11? 396. So positive 396, all divided by 2 times 18, or 2 times 9 is 18. So what's the 36 plus 396? So x equals 6 plus or minus the square root of 432 divided by 18. So what can we do to help with the square root of 432? So that's where we can go back and just use the red. We're trying to break it down. So what are two things that we can break this down into? So yeah, we're just trying to simplify that. So what was somebody started saying something? What was it? So you can break it down into 9 and 48. Then what can we break 9 down into? So 9 can go down into 3 and 3. What about 48? Two and 24. Then we can break 24 down a little more. What about that one? Two and 12. Oops. And then what can we break 12 down into? 2 and 6. And we can break 6 down one more time into 2 and 3. And now we have to look at how many pairs we have. So we have this pair of 3. We have this pair of 2. Then we have this pair of 2. So then when we're breaking this down, we can bring out a 3, a 2, and a 2. So we have, oops, don't want it to be green. So we have 3 times 2 times 2 times the square root of what was left. Yeah, it was just a 3. And then we have 6 plus or minus that divided by 18. So what's 3 times 2 times 2? What was it? 12. So then we have x equals 6. I didn't write that low enough. X equals 6 plus or minus 12 times the square root of 3 divided by 18. So then we just got to break that down a little bit more because it can just go into 6 plus 12 times the square root of 3 divided by 18 and 6 minus 12 times the square root of 3 divided by 18. So then you just have our two solutions right there. Can we simplify those anymore? So a couple people said yes, a couple people said no. How can we simplify those a little more? Yeah, so we have these. I have to add another slide real quick. Go away. So we had 6 plus 12 times the square root of 3 divided by 18. So you said divide them by 3. So what that looks like is kind of when we're taking out the greatest common factor, we're looking at what the greatest common factor of these two things is and this thing at the bottom. So 3 is a factor of all of them, but it's not the greatest common factor. So yeah, if we look at 6, we can have 6, take that out front, then we get 1 plus 2 times the square root of 3 divided by 6 times 3. And then these two things, the 6's on top and bottom will cancel each other out. And then to simplify it, we just have 1 plus 2 times the square root of 3 divided by 3. So that's a simpler way to write what we just had. Does that make sense? Do you guys have any questions about that? So the 6 times 3 is 18. So you can bring this 6 outside of it and have it 6 times 3. And then the two 6's will cancel out. So the 12, when you distribute this 6 back into it, yeah, you just divide everything by 6 and it cancels out. Does that make sense? Cool. So then looking at the next problem, number 3 was negative 2x to the 4th minus 10x squared equals negative 8x to the 3rd. So is this in standard form? No. So what do we need to do to make it in standard form? Add the 8x to the 3rd. So then we have negative 2x to the 4th plus 8x to the 3rd minus 10x squared equals 0, which that's in our standard form. But then the next step was factoring out the greatest common factor. So what's that going to be here? 2. Then what about with our x's? What's the most amount of x's that we can take out of all of these? X squared. So if we have, you want to make it negative? No. So yeah, if you're taking this out of all of these, you could make this negative. So the negative 2x squared will make this positive, this negative, and this positive when you're factoring it out. So if we had a negative 2x squared here, they would just have x squared plus 4x minus 5. Except I did that backwards. These two things need to be switched. Need to be plus 5 and minus 4x. Because then when you're multiplying, if you want to multiply this back into it, you're just trying to figure out what you would take out to get this back at the beginning. Does that make sense, or did I just explain that really weird? All right. So now that we have this factor, we have the negative 2x squared factored out, then we have this quadratic that's right here. So with the negative 2x squared factored out, what is our x going to be that makes this whole thing 0 for this part? Yeah, again, it's just 0. So if x equals 0 here, then that's going to make this 0. This part's going to be 0, and 0 times all of this is going to make this 0. So therefore, the whole thing's going to be 0, and that's one of our solutions. So then what we have left is this x squared minus 4x plus 5, which is a quadratic, and we can use the quadratic formula. So what's our a, b, and c going to be for this one? A is 1, B is -4, and C is 5. So then, when we're just plugging that in, it's x equals -4 plus or minus the square root of -4 squared minus 4 times 1 times 5, all divided by 2 times 1. So if you guys put this part into your calculator, what's all of that going to give you? The -4 squared minus 4 times 1 times 5. -4? All right. So then we have x equals 4 because the -1 times -4 is 4, plus or minus square root of -4, all divided by 2. So what's the square root of -4? Yeah, it's just going to be 2i. So then we have, make this a little lower, x equals 4 plus or minus 2i divided by 2. So can we make this any simpler besides breaking it down? Yeah, we can divide all of them by 2. So if we divide all of them by 2, what are we going to get? So you get x equals 2 plus or minus I divided by 1. So when we have all of them divided by 2, we get 2 plus or minus I divided by 1. And when we split that up, what's our two solutions going to be? Yeah, so x equals 2 plus I, and x equals 2 minus I. So then we have our three solutions being x equals 2 plus I, 2 minus I, and x equals 0. You guys have any questions about that one? Oops, sorry. I didn't mean to hit it yet. Are you guys ready to go to the next one? Do you guys have one more? No. Oh. That's okay. So do you guys have any questions about this? So apparently I was looking at one from last year that had an extra one. So you guys don't have an extra one. So do you guys have any questions about anything that we went over? Do you guys understand getting it to look like taking what you have, factoring something out to get a quadratic, and then using the quadratic formula to solve it from there? You guys have any questions about that? Then for the rest of the period, you guys have the workday that you can work on. The worksheet for this, there's another set of notes, other worksheets, but definitely getting the worksheet done today would be a goal. So you guys already look like you're working on that. So I'm done talking. I'll be there in 1 second.